Hello everyone. So today we will solve together this machine problem in statics, and we have a special pair of scissors and we try to find, so the goal is to find the force on this little, let's say it's a little wire that we want to cut. Okay, so step number one, and I already did it to save some time on the video. Step number one, free body diagram of each body. Okay, so what you need to do is you need to split them. And after we split them, we will now draw together the force on each element. Okay, so let's look like what we have. We know that on each handles we have 150 Newton. So we can, and that's a blue force, blue force, because we know it. Oh no, here we go. I'll try to just remove the little arrow there because it's not red, it's blue. So we have one force there and one force there. I draw them in blue because we know them, okay? And we can even write the value 150 Newton and 150 Newton. Okay, what we are looking for, and I need to draw the little wire. Let's draw it there. What we try to find is those two forces there. So let's make me arrow, this one and this one. Let's call that F and F. They will be the same. That's the one that we try to find. So now let's spread the different forces, look at the different shape, etc., etc. So if we have the force on the little wire, we have some forces back on each, on that piece there and piece there. So that means that this force on the top will go, this one will go down, so this one will go up, and this one will go down. Okay, so that's the same force that we are looking for. Let's call that the force F and the force F. That's the same than the wire. If we look, let me draw some, let me give some name to each point. I will draw them in green. Okay, we have the point A there on the middle. So this one is for this one, that's the point A, and this one, that's the point A. Okay, that's the two forces there. We need some other name. So I will call that B, I will call that C, and I will call that D. So let's draw those points. We have B, so B is on the bottom handle and the top pin connection of this little link, and C is the bottom of the link between this one and the top scissor, so this one. So they are the same. That's what I try to align them. And the point D is this one, D and D. Okay, we have a lot of points. What do we see there? There's something interesting that we can see. In this link B, C, we have only two pin connections. So that means that we have a two forces member. So we have some forces on this link. Are they pushing? If you want to see that it's pushing, we need to look at this one. If we look at this one, okay, this yellow one, and we do the moment about D, the 150 Newton will turn in that direction. So the force on B should be down. So we have a force at B down. So on this link, it will go up. That's the same force. Make sense? Because of the moment about D. Let me remove this yellow ups so we can see. Oh no. Okay, let's do like this. So if the force at B on the link is up, at C it's down. If it's down on the link, it's up on this little handle, little on the, I will, let me draw some color on the blue handle. Okay, I will call that the blue handle. I will call this one the yellow. This one will be the green one. And we will have the little link. Oops. And we will have the little pink link. Okay. And now at A and D, at A and D, we have some forces that we don't know, but we can try to get some directions. If we look at the yellow handle, and we do the moments at the 150, we have at B it going down, so at D it should go up. So go up there, go down there. And now if we want to look at the force at A, we can look, for example, at the blue scissor. I am at F, and at C we have a moment going up, like going in the negative direction. So at A it will go down. So I have a force that is going down and a force that's going up. So we are able to find all the directions. What about the forces on X? There is none. There is none force on X. Okay. Is there none? Can we have some at D? We cannot have some at D because we cannot have some at B because of the link. So all the forces are vertical. Okay. We need some dimension, but maybe before I draw the dimensions, let's look at the strategy. What can we do? We know only two forces, the 150 Newton. So we have option 1, green one. I will begin to draw. So option 1, green, or option 2, we have the yellow. That's where we know some forces. So we have to begin somewhere where we know some forces. If we look at the green, we have 1, 2, 3 unknown. If we look at the yellow, we have only 2 unknown. So yellow looks a good start, okay? We have 2 unknown. And we can use an equation of moment with the 2 unknown at B or at D. If we do B or D, if we use an equation of moment, we will find the force at B or the force at D. So that sounds a good strategy. Very good strategy. So let's say option 1, moment at B or moment at D. If we do the moment at B and we find D, we have D on the green one, but still 2 unknowns. If we find the force at B, we have B, we have B, we have C. If we have C, with the question of moment about A, we can find F. So step 2 will be the blue one, where we have, when we know C, so we have 2 unknown left, and we can use an equation of moment about A. Okay, so let's repeat. We decided to go with the moment about D, find the force B. After we have the force B, we have the force C. And when we have the force C, we do the moment about A and we find the force F. Okay. So we need some dimension. When we do the moment about D, we need the dimension from D. So we need this dimension from B to D, that is 30. And we need this dimension, this one. Okay, ideally you put it outside the parts, but me, it's everything on it. So it's 80 plus 30, we have 110. That's for the moment about D. And when we do the moment about A, what we need is the distance between C and A. So C and A, not D, C and A, that is 80. And between A and the wire, that is 30. I think we got everything. So we think we will not even use the green body, the green element. So let's solve some. Let me try to use all my space for you. Here we go. Sum of the moment about D equals 0. So I am on the yellow. Oops, I do the steps now. I am on the yellow body. Sum of the moment about D equals 0. Well, I have 150 times 110, and this is in the negative directions, like this. and I have plus in the positive directions FB times 30 equals 0. So I got FB equal 150 times 110 divided by 30. Let's make 50 times 110, so 5500 Newton. That's my FB. FB equal 5,500 Newton, so FC equal, using the pink link, I can say that FC equal FB, so equal 5,500 Newton. That's a 5. Can you see that it's a 5? It's a 5. And now third, I go at the blue body, and I do sum of the moment about A equals 0. We have the force Fc times 80 going negative, plus the force F times 30 equals 0. Equation of moment about A. This one is in the plus direction. And we got, so what we are looking for is FF. So FF equal the force Fc, that is 5,500, times 80, the distance, divided by 30. How much is that? Let me calculate. Oops. So it's equal to 14. Yes, 14,667 Newton. So conclusion, we apply 150 Newton, and on the wire we get 14,667 Newton. That's about 100 times the force that you apply, that will be applied on the wire. And you see why it is much more efficient to put the wire next to A than on the bottom, like there. Much more efficient to meet closer to A. So that's pretty cool, Scissor, right? Great to cut anything. So I'll let you redo this with your different data. Let me know if you have any questions. And final answer, this one, in our case, when we have 150 Newton at the beginning. See you later. Bye-bye.